So I'll talk about VR map. OpenStreetMap goes VR. This is basically about simple geodata visualization with a library called A-Frame. I'm Robert Kaiser, as he already mentioned. Nickname is Cairo. I'm a Mozilla tech speaker, which is a community position. I'm not working for Mozilla. This is not official Mozilla stuff. The project I'm talking about is not official Mozilla stuff, but it uses a lot of Mozilla technologies. I'm a freelancer right now, but not working for Mozilla. The slides, if you want to click any links or anything or look it up later, are at slides.cairo.at. Right now, just the first entry there. And let's go to the topic of VR. Has any one of you used a VR headset before? There are quite a few. Has anyone developed for VR? Very few. Okay. So what is WebVR? It's a virtual reality system powered by web technologies. This was the first name they had when people stepped into the connection of the web and virtual reality. Nowadays, they put additionally to VR, they put AR, augmented reality, into the same collection of standards, and it's now called mixed reality or XR, WebXR, or the WebXR device API as the full name in the W3C proposals. That's, as I just mentioned, a proposal for an open standard, but already to a large part implemented by multiple parties, including Mozilla, but also including Google, Samsung, Oculus, and a few others. It's basically taking WebGL, web audio, gamepad APIs, and putting a few additional things on in addition to that concert to make VR available. When it comes to Mozilla, it's fully supported in Firefox release on Windows. On Mac, it was put on release in Firefox 60 and pulled back in 60.01 because of some small issues. So it's on nightly and beta right now on Mac. On Linux, it's still in development to some degree because the drivers for the HTC Vive, Oculus does not have Linux drivers because Facebook doesn't think it's a good idea to do with Linux, apparently. But Valve does drivers for the HTC Vive. And those are in beta mode as well. And Firefox has to do some GL graphics hardware acceleration patches before we can enable the support for VR itself. Most of the actual VR support is there, but the interfaces need to be done. That said, Mozilla is the first one who shipped support in a release version. Others of the major browser vendors, others have, Google has something in experimental stuff, and well, Microsoft has something in Edge for the HoloLens, but only for the HoloLens. So what is VR map? I asked before about your knowledge about VR stuff. Who of you has used OpenStreetMap? A lot of you. Who has actually done some contributions for OpenStreetMap? So a few who know a little bit about the concepts. But most don't. I'm involved in the OpenStreetMap project and I'm involved in Mozilla stuff, and I thought, well, I'm doing VR stuff for Mozilla. I love OpenStreetMap. We could connect that somehow. And so I did a little demo for WebVR stuff using live OpenStreetMap data, and that's what VR map is. In 2D mode, you can use it in any modern browser. I actually put a few things like Fetcher in it, so you need a modern browser, but you can use it in 2D mode. It uses WebGL, no issues there. But where you have WebVR, you can use the controllers, you can use the headset. It's using Mozilla's A-Frame library. I'll come to that later. Right now, it's very simple, about 70 lines of HTML. More than half of that is actually the start dialog that tells you what it is, and about 400 lines of JavaScript, not more than that. And I'm talking a bit fast because I want to show you a little bit of it, and I also want to show you a little bit of code. So let's take a look at it. I'm actually using a locally hosted version here. And this version loads a bit more data than it usually does. Actually, a little bit too much data for using the headset. But I want to show you a little bit of a larger area here. So we are standing actually right in front of this building. When I load this local version by default, when you load the official version, you're standing right in front of the building I live in. I will make some coordinate selections available in later versions, but you have to start somewhere. So why not in front of your front door? And let's actually use the ASDW keys and walk towards the Gürtel. And I can actually fly. And you see that even the trees, so you see there's actually three things there. You have the ground tiles where you see the map itself. You have buildings and you have trees. The reason for that is pretty simple. The ground tiles were the first thing I did to actually see something. And then the easiest thing to do something with was something that is a node, so that is a point on the map. So I looked at the map and I saw trees, so I thought trees should be easy. So I put trees on it. And then buildings are a bit more interesting, so I put buildings on it, just to show something off. OpenStreetMap at some point imported open government data that says the size of the trees, so I could actually use some data about the size of the trees, so you get different sized trees here. And yeah, as I said, you can fly around there. If you have the controller, you can jump around there with the controller as well, or fly through the area. And I'll reverse fly up here. You'll see that some buildings have different sizes, but many of them are rendered in the same height, which is also depending on which data is available in OpenStreetMap. So a very simple thing, actually. How is this simple thing done? So one of the first decisions I made with it to make everything simple is I decided that the world is flat, actually in two ways. For one thing, you saw we are actually on some kind of slope here, and on this map it's all flat. You don't see anything go up and down. The second thing is I decided the world I render here does not have a curve. It's just flat. And before the flat earthers rejoice too much, I'm actually, for the ground tiles with Mercator projection, I actually calculate the size of the tile. Mercator projection has this nice habit of the closer I always have a problem with which lines on the globe are which, but the smaller the area gets in one direction, the smaller the tiles get in the other direction as well. So you always have square tiles also in size on the ground, but I'm taking the actual size because the coordinate system is in meters, so it actually fits correctly. So I actually have to respect the globe even though my world is flat. For the trees and buildings, I take live data from the Overpass API. The tiles are not coming from the Overpass API. I actually take the standard tiles from OpenStreetMap through my own tile caching server that I have for other purposes to not tax OpenStreetMap too much in terms of traffic. And then there's a camera and controller setup, which is not dynamically built. It's a static thing that's defined in the HTML. You will see that. And yes, as I said before, it's all built with A-frame. So I have mentioned A-frame quite a lot. What is it? A-frame actually is building on top a second layer on top of WebVR. There's a first layer, which is Three.js, which is a JavaScript library doing all kinds of 3D stuff on top of WebVR. But you still need to write a whole lot of JavaScript boilerplate to initialize scenes and whatever. So A-frame puts a second layer on it to make it that simple to work with that. And it uses an entity component system, which is something game developers probably will know very well, and anyone who has seen Minecraft will know, because it's basically, you have blocks, and then which are the entities, and then you have components which give properties to those boxes, the blue one, a wooden one, a steel one, whatever. Same thing here in A-frame. The first thing is you have everything in that is any A-frame stuff enveloped in an A-scene tag, and then you have your entities inside there. There's a few specialized entities. There's an A-entity, which is a general entity, and there's some specialized that you see here. That's just a very simple hello world thing that just shows how the structure works. You have a sphere, a cube, a cylinder, a plane, and the sky is actually just a sphere that goes all around you, and you see the inner side of it. You even can do simple animations just with HTML tags. So for those people who just want to start up with stuff and don't know much JavaScript at all, even, they can just use that. But as a JavaScript developers, which you all are, you can actually use all those DOM entries in the DOM tree and can manipulate them with JavaScript. And then you can even go to the Three.js stuff underneath if you want to do more specialized things. The components are just HTML attributes with some values inside of them. So how does that map to my example? First, I'll tell you a little bit about the structure I built there. The index.html has, of course, the includes for the JavaScript, the start dialog, and then this general thing you just saw with the scene and the static stuff, which is the camera rig and some basically grouping entities where the dynamic parts will be put in. Then there's a map.js, which is my main thing with variables, load handler, and the function for fetching, just the general function. Conversions are boring, just mathematical stuff, coordinate conversions. Then there's position limit.js, which is an A-frame component that I wrote myself to limit where you can fly. Because with the first variant I did with the WASD keys, you could actually fly through the ground and go underneath. And that didn't look too good. So I wrote a component that actually limits that. And we'll take a short look at that because it's a nice example for a component. And then there's the 3 JavaScript files for the 3 types of objects, buildings, tiles, and trees. It's available on GitHub. Cairo-AT is myself, and just called VRMap. There's a link. If you go to vrmap.cairo.at, where the example lives, you find a GitHub link there as well. And actually, no, we will not go to the questions yet. We will actually take a look at the actual code, because that's more fun. So, index.html. The most interesting thing here in the head, you have a lot of JavaScript includes, but the most interesting one is this one. That's actually the include of A-frame itself. And then underneath it, you have just through a CDN link, you have some A-frame components that I'm loading. Most importantly for all the things you do with the controllers and with the keyboard controllers, and to be able to even fly around with a touch screen and stuff like that. Awesome to GeoJSON converts what I get, the XML I get from the Overpass API to GeoJSON, which is more convenient to work with in JavaScript. And then there's includes for my JavaScript. Very boring intro dialogue, and here's the fun stuff. So it's an A scene with just a background color, so that the sky is, in this case, not actually a sphere, but it's just blue all around you. The ground is just a workaround thing for the teleport controls. They do not work with planes, so I had to introduce a box for them. And here's the general groupings for the dynamic stuff. The tiles and items is both trees and buildings. The camera rig is also an entity that starts off at position 0, 0, 0. So all the coordinates are in meters and triples of numbers. On this, I put the movement controls, which allow me to fly around. And I think, yeah, it also tells me where the camera is. And here's how I use my own component for limiting the position. So the whole camera rig is what's moved around. The camera itself is basically where your head is in VR. And then the camera rig also has entities for the controllers to be able to display them. And the whole rig is moving around, and I give it a position limit on the y-axis. So the y is actually the vertical axis, x is the horizontal axis, and z is the depth axis. And I limit y to 0 and, as a minimum, and I actually put in a maximum of 100 meters, but that's just because I felt it's nice to have it in the example. As I said, there's a camera. That's an entity with a camera component, which is the head, and the teleport controls. If you want to put something on multiple tags, you can define a mix-in, and all those components that are on the, and with an ID, all those components are applied everywhere you say mix-in equals that ID, which makes it easier for coding. And I'll just, we'll just take a look at two other source files for a little bit. I don't want to go too long here. I just want to show you how you define a component for A-frame. This is a very simple component for the position limit. I actually defined it so you can do minimum, maximum for all three axes, but I'm only using the y-axis in this example. I might actually submit that as a general component. I didn't get around to that yet. Schema says which properties it supports with types and defaults. And tick, you can actually have an initialization function if you need that. But in this case, I don't need any initialization. Tick is called at every time anything is moving in the scene, up to the frame rate that you have, which on the headset is 90 frames per second usually. And so you should only do very short things in a tick function. Nothing that takes long to calculate. And in this case, it's very simple. It just says if the x-min is defined, and here I go down to, this is the 3JS object underneath my object, the object 3D, and then I go to the x position from it because it's more performant to query and manipulate the 3JS properties than to go to the DOM tree for it. And I just say if it's smaller than my minimum, then I set it to the minimum. So very simple to understand. It's more interesting to deconstruct how I go through to the 3JS stuff than what I'm actually doing. because that's what you would do as well, and that's everything it does. But it's a very nice and small example of how you do a component. And I'll take a look at the buildings at the end. We can always go to more depth if personally if you want to, but I think I'm not too short on time anyhow. So buildings, this is how you query overpass. I will not go into that. This is how you do a query on OpenStreetMap, which I just hand over to my fetch from overpass function, and I already get the GeoJSON back because I put that into my fetch from overpass function, the conversion. And for every feature in the JSON, I call add building. And I actually have a bug here. The error message should be couldn't draw building here. Copy and paste. Yeah, add building. I return a promise so that it actually paints everything asynchronously and stuff. Other stuff can happen. And I create an A entity, put a class on it, and calculate the points, and just put that in the geometry component or attribute with primitive building. And I actually register a geometry which just works the same way as I defined a component. I can define a geometry and therefore have different geometric objects in my scene. And the geometry building actually gets all the outer points and the inner paths. The ugly thing there is that I have to actually parse strings. But the nice thing about it is that I abstract it to a degree that we can actually write some HTML and put stuff in, and you can also use the same inner workings of all this. You can even take a rendered scene from OpenStreetMap data and serialize it into actual HTML that you can load at any time. I didn't implement that, but it's possible that way. And there you have an init function, so something, you could use an init function in a component as an initialization function. And here the init function does all the heavy work. It builds up 3 vectors, a 3 shape, and then the 3 shape is extruded to a height. So nice function of the 3 shape is that you can actually specify holes. So I did get that functionality for free to have buildings with holes. And then I can extrude that shape even with the holes to a certain height. Putting roofs on it and so on would be more difficult, but just extruding it is very easy here. And then I have to do some strange rotating to actually put it in the right place. And I didn't completely understand why I did need to do that, but I found out it worked. And yeah, that's basically all I wanted to show here. I think we can go to questions, and we can also talk about it in private afterwards. If anyone wants to actually experience something of this in VR, and we have the time after all the talks and discussions, I can actually put up the VR stuff, but only if it's wanted. It's put up in about 5 to 10 minutes, but I have it with me if anyone wants to. That's about it.